Hey guys, my name is Yusuf. I'm the Community and Academic Program Manager here at SimScale.
Hey guys, I'm Meg and I'm the Content Manager at SimScale.
Together, we do a podcast about engineering and our customers using SimScale for their simulation purposes.
Hello, David, and thank you for joining our podcast. Could you please give us a bit of an introduction about yourself and about Gruner and what you do there?
Of course. As you say, my name is David. I'm living in Bern. I'm working for Gruner Roschi. Gruner by itself, it's a group firm. It is well known in the construction sector here in Switzerland. We have around 800 employees, and Gruner is basically building construction, energy, infrastructure, structural design, and environment, and fire safety. So we do a lot of stuff. And here in Bern, at Gruner Roschi in the office, we are around 50 people. We are mainly planning the HVAC systems of buildings. And I myself, I'm not an HVAC engineer. I studied energy and environmental techniques in Rapperswil. And then I landed here in Bern in a small team of 5 people. And we are doing all kind of simulation. In the most part, heating, cooling loads, energy, thermal comfort simulations for our engineers here in Bern, also for all the Gruner engineers in Switzerland, and of course for contractors. Yeah.
Mm-hmm.
So that's my background.
What motivated you to go into the energy sector?
It was a big part in my study, basically. The study was pretty wide. I didn't know exactly where I'm going. It was more like of my bachelor thesis. I did a simulation, and then after the study, I was looking for a job around simulation, and that was the reason why I landed in Bern, basically. And that was 3 years ago. Sorry.
Oh, okay.
So you first came across CAE during your bachelor thesis, or was it even before?
It was during my study. It was the first time I came in contact with it. It was CAD modeling and doing CFD. Yes. And I did not remember what was the first project I did, but I remember the first experience was, oh my God, it is complicated, it is expensive, and it is a lot of effort. Yes, basically.
How long do you think it took you to grasp it?
I think you never stop learning. So I discover every day something new. In every project, you learn something for the next project, and it go on, and then new things coming, and you learn steady more and more. I think it's not a time where you can say, I know everything, and I think that will not happen. Yes. So for myself.
Good answer.
What is your main focus at Gruner Roschi in terms of simulation? Do you only do one type of simulation, 2 types, or are you like an expert or expert, quote unquote, in different fields?
Different fields. So we have, I would say, main part is all the building performance simulation. So all about energy, cooling, heating loads, and that's a really big part. And the other part, which is growing more and more, is CFD. Basically, CFD, also thermal comfort, but in a much bigger scale, in a much more detailed scale, and choosing making a proof of concept with different design. This is also a part which becomes more important. So it's a thermal thing and it's the CFD. So basically those two things. Yeah.
So from when you started, sorry, go ahead, Josef.
No, you can if you want.
Okay. I'm just wondering, over the course of your career, so you said that you graduated like 3 years ago, and I'm just wondering like if you've seen like a design process change here, like while you've been working professionally in terms of building performance and simulation.
This is a good question. So I can say definitely yes. I'm only 3 years in this business, but when we just talk about general simulations, not only safety, for 2 years, when I remember back, we had to do a lot of works manually, and what then we had, this leads then to problems that simulations are expensive. And this is something that lots of people have in their minds when they hear simulation, it is expensive. And now 2 years or 3, let's say 2 years later, I can say, or we can say, we are 2 or 3 times faster than before with providing the same quality and can provide more information. And I can tell you how this happened. There are two, I think there are 2 major factors. One factor was the evolving of the BIM method in Switzerland. So the BIM method is how you work together. It's a workflow basically, and it strongly depends on the 3D models and the information. And now that the architects have to draw, they don't have to, but mostly they draw in 3D. So now we have the 3D models and can work with it. So we don't have to do all the modeling. So we have a good basis, and now we can build up on this. This really helps to get faster and lower the cost of the simulation. And the other factors are tools and softwares. There are lots more tools, especially smarter tools, so which you can automate workflows. And the other big factor is the connection between the softwares. It's much better. So I have a CAD model from Vino, Akeret, or whatever. I can import it into my software. No problems with converting or wasting time. So I have the same quality in this CAD model like in this one. They have connections between offer. They have connections to the cloud. I can have all the time, I have access to the data anywhere, basically. And this is also a really big process what happened in the last 2 years. Better connections between the software and smarter software, basically. Yes.
Sounds very interesting. Excellent. What I want to ask you about is, we mainly talked about pre-processing now, what's called pre-processing, like CAD and mesh, if you want to put mesh into the pre-processing step. Can you talk about the simulation step? How can you make sure that the boundary conditions are correctly applied in your simulation? How do you approach that?
Okay, that's a good question. It depends. I mean, all the information I need then before the simulation. So that this is the questions: where do I get the informations? From whom and which quality? So basically, let's say for a building which is not built. So what surface temperature do we have, or are we going to simulate a worst case scenario? You can always do this if it's go worse, and it will work. So it will work for all the cases, basically. And the other thing is, what I made a really, really nice experience was, there was a building there. They had some thermal comfort issues, and they contracted us to find out what is the problem which causes the thermal comfort problems. And what we did is we went there, also we visited the place with a heat camera. Then we took the picture for all the surfaces, for example, and we had then the exact surface temperature, for example, and then we used them as a boundary conditions for the simulation. Then we had a simulation which was exactly the same like in real. And then we saw in the simulation, we saw exactly the problems which they had, and then we could make some adjustment on the model in the CFD model, and we then saw what is the best solution, basically.
Okay, got it. And what technical solutions do you use for your simulation process?
What do you mean with technical?
Like IT solutions in terms of CAD processing and so on.
You mean which software we use?
Software, yes, exactly. Yeah, for every step, or do you have something?
For every step?
Yes.
Mostly for CAD modeling, Revit. It's for CFD we go into Revit because it's an architectural software and it has really good connection to other architect softwares. And then in Revit we will basically you cannot just take the architectural model. This is way too detailed, so you have to simplify it in Revit, make it better for the CFD, and then we go basically into SimScale. And that's more or less a process for CFD.
Cool.
And
okay, Megan, you can continue if you want.
Okay. I might have a bit of a lag. Sorry, guys. So speaking of SimScale, I want to read a quote now that we have from you from one of our other collaborations where we wrote a success story together, where you say, working with SimScale gave us the possibility to inspect which of the architectural and technical solutions works the best way and gives us certainty about our decisions. One other big factor is the speed in which SimScale can deliver results through its great parallelization capacity. Without SimScale, we wouldn't be able to deliver high quality results in the required time period. Bit of a long quote there, but can you please maybe elaborate on that?
Yeah, I mean, yeah. Where should we start? Also, maybe I have to go back a little bit. I mean, the thing is, if you we had the CFD software we had before was really not up to date. So, and we searched then for a better software. And I did my research, and what was a big part, what an important part, was to have it not locally on our PC, because we didn't have the IT. We didn't have the hardware. So we came across SimScale and we thought really, okay, it's cloud-based, we don't need hardware, or we just can create an account, then we can start simulating. So there's really nothing ordering or whatever, software installation in a big company. Oh God, this is complicated. You have standards there and there. Then hardware, you have a standard PC, you don't get much performance, and it takes time, and this was just the best solution for us. And it's still, after 1 year, it's the best solution for us. So we got into SimScale, and then we also discovered the possibility with SimScale, because before that we didn't have that. We had a program that can not run in parallel. So you got one model, you can do one simulation, then you have to wait 1 week. And this is not in the building construction business. You can't do this. So when someone comes to me and he needs something from me, a simulation, it needs to be done for the next day, basically. And this is also a really huge contribution, especially if you have then special geometry, which you need different meshes, different finesses of them, or different boundary condition. I can do this in SimScale in parallel, run it, and next day I have 20 different variants, no problems, and then I can choose really with which one I go for. Yeah, I go further. And before that, it was absolutely impossible. It would take months months to do that. And I can do this now in a couple of weeks. And this was a huge improvement, besides not having needs of hardware and software installation. So all you need is a login, and then you can start simulate. And this is really excellent. And I think this is also the way it goes in the future. I think it goes away from this having power locally somewhere under your office table and not be able to, you lose flexibility. And actually how I work, I only have a laptop, a pretty weak laptop, and 2 screens. That's all I need. And everything else is in the cloud or on a server. And I think this is also the future. It will go in this direction.
Excellent. Yeah. Okay, David, maybe one last question before we say goodbye. So how would you say, how can CAE tools help facilitate this growth?
Yeah.
In terms of where CAE goes into the future and so on.
Yeah. So for our business, there are different needs. So one of the needs is having calculation done. So you can do it by simulation, or you can do it by hand. And in most cases today, you can only do it in simulation. And that's basically to get a velocity profile, to get the PPT or pressure gradients force. Another big important part is to have proof of the concept for specific design or for comparing design with each other. Especially in the HVAC engineering, there are so many designs possible. For example, having multiple inlets, the location of the inlets, the geometry of the inlets, all of them having an impact of the flow, how it will be distributed in the room. And now you have the tools. You can simulate them, you can compare it to each other, and then choose the best design option. And this is also not only improving your own design, but more importantly, you have the proof for the contract so that your design will function in the reality. And I think this is really a big important part. And the third part is, I would say, is performance gaps you have already built. You have some issues there, thermal comfort issues. Then you can create it with your simulation tool, and then you can identify the problems and then search for the best solution, basically. Yes.
Excellent point, David.
Yeah. Then thank you very much for this invitation, and then we will see you later.
Sure. Thank you, David.
Bye, guys.
Thanks,
Bye-bye.
David.